Hi everyone. In today's lesson, we'll be taking a look at what is meant by a logarithm, or log for short. So in your notebook, please put down today's subtitle, which is Logarithms. Well, in plain English, the definition of a logarithm is quite a mouthful. The definition is the following. A logarithm in a specific base, which we'll call c, of any positive number, which we will denote as the letter n, will equal to an answer, which we will denote as the letter m, where the base, c, exponent, the answer, m, will give back our positive number. Now, I'm not surprised if you don't understand the definition, because it is quite a mouthful. But perhaps with some mathematical symbols, it might make just a little bit more sense to you. What this definition is saying is that if you have a logarithm in a certain base, which we'll denote as c, and usually it's written down there, of any positive number, let's denote as n, should give you an answer, which we will call as m, and that will happen because if we were to take the base, the c, and exponent the answer, m, it should give back our number, n. So, when I present to you the definition in symbols, does it make a little bit more sense? If not, well, let's try a few visual examples with some actual numbers to see what a log actually does. So, first visual example involves the following. Suppose I ask you this question. 3 exponent something gives us 9. Well, as you all know, that something will have to be 2, because 3 exponent 2 gives us 9. And here is where you will finally see how useful a logarithm is. A logarithm will help you determine the missing exponent. A logarithm is written in the following manner. We write the word log, and as the above definition states, the base, in this example which is 3, is written kind of below the log, and the number 9 is written next to the log. And the way we read this is log base 3 of 9. And the usefulness of a log function is that it tells us what the exponent should be on the base 3 so that it will produce the number 9. And as we all know, that will be 2. And this statement is true because the base 3 exponent the result from the log, which is 2, does give us back the number that we were logging, which is 9. Are you guys still lost? Well, if you are, let's take a look at another visual example. And the more you see, the more you will get used to the way a log is written. For our next example, let's try the following. 5 exponent something gives us 125. As we all know from previous experience, we know that the exponent will equal to 3, because 5 exponent 3 gives us 125. The big question is, how do we rewrite this in log format? Well, let's go over one more time how to write it properly. We start by writing the word log. The base 5 is kind of written below the log, and the number that we need to figure out for our log is 125 equals. So this is telling us log base 5 of 125 should equal to the result, where if we were to do 5 exponent the result, it would give us back 125. And as we all know, it's going to be 3. And the justification is simple, because the base exponent our answer gives us back the number that we were logging, which is 125. Why don't you try the next one on your own? Suppose I give you the following. 2 exponent something gives us 16. And as you all know from past experience, the exponent should be 4, because 2 exponent 4 gives us back 16. What I want you to do is rewrite that result in log format. Go ahead, pause the video, and try it now. Alright, let's see how you guys did. So we first start by writing the word log. Base 2 is kind of written below the log, and the number we're logging is the 16. And here's the usefulness of a log. It helps us figure out what the missing exponent should be. But, as you already know from experience, the exponent is 4. Why is the answer 4? Well, because 2 exponent our answer gives us back the 16, the number that we were logging. I hope that these 3 very simple examples will at least make you realize how important a log function is. A log function will help us determine any missing exponent for any combination of base and result. Now keep one thing in mind. The 3 examples which we just completed all involve combinations of bases and results for which you've had experience with. You've seen some of these combinations many times in the past. But to highlight the true usefulness of a log, we'd have to look at something which you have not perhaps experienced. Something such as 2 exponent what gives us 10. This is one where you may not have experienced, because the exponent, as you can probably tell, will not be a nice number. So, big question is, how useful is a log in this situation? Well, when you rewrite it in log format, again, let's review how to write it. First, we start with the word log. The base 2 is kind of written below the log. And the result of the exponential is 10. What a log is basically asking is 2 exponent what gives back the 10. And in later lessons, you will learn that the result of this following log is around 3.32. Why? Because 2 exponent the 3.32 will give back around 10. And this is why logarithms are so powerful. They can help you determine any missing exponent for any combination of base and power. And this, ladies and gentlemen, is what is meant by a logarithm.